Okay, everybody, welcome back to our Algebra 1 virtual tutor. In this section, we're going to cover Objective 25. So we'll want to have our 25 packet here ready to go. And let's take a look. We'll get right into it. In Objective 25, we're going to determine whether two lines are parallel or perpendicular. So we're talking parallel versus perpendicular in this objective. And the other key part here I see is that we're talking about lines. So we're going to be talking about linear equations as well. So we'll want to think back to what is parallel versus perpendicular. And that's really what the notes here are. Two lines that don't intersect or touch at any single point is what we're going to be calling parallel. Now in geometry, in geometry, you will explore a little bit more about the fact that these lines have to be in a plane. But here in Algebra 1, we're really only concerned with the fact that they don't touch. So here we can see that we have lines M and N, like so. And those in algebra are going to be two linear equations. So they can have y-intercepts, they can have slopes. And that's really all we've learned about y-intercepts, slopes. Well, what makes these two lines parallel? The fact that the rise over run is going to have to be the same, in both of these. Which means if two lines are parallel, they're going to have the same slopes. And if we're going to determine, remember our objective says determine if these two lines are parallel or perpendicular, we're not going to look at a graph and tell, we're going to look at the slopes. And if the slopes are identical, then yes, these lines are parallel. Well, it turns out we can do the same thing with perpendicular, and that's what this bottom part says. Perpendicular means they do touch, they touch once, but the key is they touch at a 90-degree angle right here. And this means perpendicular. Perpendicular. Now, we can see immediately in regards to slope that if you've got two lines touching like this, one of these lines is going to go like this, and this is going to have a negative slope. That means the other line would have to have a positive slope. Excuse the bells there. So immediately we're going to have one positive, one negative. Well, it turns out that in addition to opposites, they're also going to be reciprocals. So we're going to say that these two lines, if they're perpendicular, have opposite reciprocals, slopes. And we'll talk about what the definition of reciprocal is when we get into this. But they're opposite in that they have two different signs, and they're reciprocal, and that means the fractions were flipped upside down. Now, again, we're not going to do this graphically. We can use a caret calculator to start to verify it, but even that's going to be a little challenging. So we're talking more about, can we do this algebraically? Not by graphically, not graphically, but algebraically. We can use a graph to verify this, sure, but I want to talk about algebraically. Because right here, when I have y equals mx plus b, I can look at that slope and get the answer just by looking at it. And that's what we're going to do in this section. We're going to take two lines. We're going to make sure they're solved for y, make sure they're in slope-intercept form, and then we're going to look at the slopes. So we're going to jump right into the practice on these. And this is what we're going to do. We're going to take a look at algebraically, are these two lines parallel, perpendicular? Or if they're not, then they're just neither. They're just two lines. But the first step in all of these is solve for y. So in this one, in number 1, I already know that the slope is 3 over 1, mx plus b. I know the y-intercept in that is 2, or 0, 2, if I was going to write it as a coordinate. In the second one, I've got a little work to do. In this equation, it's no longer solved for y. So I'm going to take that, and we're going to have to solve this for y. So we're going to get rid of the 9x, like so. And then finish my solving for y by dividing by -3. Remember, we have to divide every single term by -3. Well, what's my answer? -9 divided by -3 is 3 plus 2. So in this equation, the slope is 3 over 1. Well, how does that compare to my first slope? They are the same. So we know, because those two are the same, our answer here is parallel. There we go. Same slope means parallel. Your job is going to have to be to find the slopes, which means we're going to have to solve for y. We've done plenty of solving for y in the past videos of this. So really, this ends up being a little bit of a review of what we've done all year. Okay, now in number 2, we can see we've got our 2 special equations. Remember our special equations. If it's y equals a number, this is always just good to know that y equals a number. What's that look like? Well, that's a horizontal line going through the y-intercept. If I have x equals a number, what's that look like? Well, that's a vertical line. So we can also remember that these two had slopes. You might not even need this part, but the slope of this line was 0. The slope of this line was undefined. But more importantly, why was that undefined? Because it was always a number divided by 0, which turns out, look at that, this is 0 over a number. This is a number over 0. They are reciprocals of each other. Now, because they're zeros, we don't worry about the opposite signs. But we can see either graphically by looking here or algebraically that these are indeed perpendicular lines, like so. Okay. Let's take a look down here at the bottom. And in number 3, again, neither of them are solved for y. So solve it for y. I'm going to take that first equation, and I do like to write them out. All right, let's subtract 3x. Okay. And in this case, we're just going to divide by -1. And my slope here is 3. All right. So let's look at the second one. All right. So same thing, we're going to subtract my 3x. And at some point, you might actually be able to tell just by looking at the equation what's going to happen. If not, here's my 3x now on the other side. Divide by -2. All right, so right here, -3 divided by -2 is +3/2, and it's important to get those slopes correct. 28 divided by 2 is 14, and here my slope is 3/2. So now when I compare these two slopes, they're not the same, they're not reciprocals, they're nothing. So these really have no relationship at all, so we're just going to say neither. Alrighty. So number 4, again, neither one of these is solved. All right. Let's add 6x. Like so. And let's divide by 2. So in this case, the slope is 3/1. Notice how I'm putting that 1 every time, because our slope is really always a fraction. So if I get a whole number, that's fine, but I always want to remember that it is still rise over run. Even right here, I probably should have put over 1 there. All right, let's do this other one, and I kind of went backwards here, but that's okay. All right, so again, same thing every time. Get rid of the x. And then divide by what's in front of the y. Oh, and you can see we got the same exact slope. So these are parallel lines. Okay, so there's our section of doing it algebraically. Now, I did say we can look at this graphically. And on the next few, I do want to look at that. Now, already we should see on number 6 here, there's a red flag because that's an x equals equation. But on number 5, we'll keep going in order here before we get to them all. I've already got the first one solved for y. So there's my slope. If I'm going to do it algebra or graphically, I still need to solve them for y. So I still need to take this second equation subtract the x. Whoops. -x plus 4. And if I look here, I already have my slope. But it's a good idea because we want to look. Let's go ahead and look at this graphically. So on my graph, and what we're going to do, let's bring over our calculator. All right, we're going to type in 2/3. And don't worry if your calculator doesn't look quite like mine. That's fine. Just type this in how you guys would normally do it. But you can see I've typed both equations in. And when I look at this graphically, here's my first line. And here's my second line. Now, we can see, looking at my slopes, these are not, whoops, I'm going to go ahead and copy this for us. There we go. And let's get a better copy than that. There we go. All right. So we can see from the slopes that these are not parallel, and our calculator tends to verify that. But you want to remember that, unfortunately, our calculator screen is not to scale. So this very well could have been perpendicular, and it's very difficult to tell perpendicular versus neither. Now, we can definitely tell parallel, so when we hit another parallel, we'll talk about that. But this is from both the slope, whoops, don't want to do that, from both the slope and graphically, our answer is neither. Okay. Now, I said number 6 is a red flag because these are my two special lines. And this one we're just going to have to know. There's no way to do it graphically. And honestly, the slopes are always going to be 0 versus undefined. You're just going to have to know that these are perpendicular. Now, I said we wanted to be aware of the fact that our calculator can give us false answers. And in number 7, looking at them right away, they're perpendicular. My slopes here are opposite reciprocals. So one's plus, one's minus, and the fractions are flipped upside down. That's opposite reciprocal. So graphically, what's that look like? And here we're going to need to be careful. So again, we'll get rid of what we already had. And again, don't worry if this doesn't look quite right. Just do your fractions however you would. All right, so graphically, here's what perpendicular looks like. And you can see, go ahead and take a little snapshot of that for us. It looks pretty good, but I would not be able to tell for sure the difference between those two. And this can get even more complicated as we get more and more close but not quite perpendicular. So that's why we're going to use not the calculator, but the slopes, the algebra, to tell us that, yeah, these are perpendicular. Like so. All right. Now in number 10, or I'm sorry, number 8, we can see we're back to having to solve these for y. But when I look at these, what's going on? Well, it might be a little difficult to tell, but we can see that the y's are the same here. That means when I divide both of these by y, I'm going to divide them both by the same thing. So I can look at just the x's and say, well, wait a minute. These values are completely different. There's no way, I think, no way that I'm going to be able to get either opposite reciprocals or the same slope from these just by looking at the equation. Now, that might be a little bit much to tell. So as always, we can write these out. Let's keep these color-coded for you. All right. So again, I'm going to subtract the 4x. And here's what I was saying. I'm going to divide by 4. And that's why I was looking at these 4's right here, because I know my last step's to divide by 4. All right, if you don't see that, just go ahead and solve them. And I'm going to get negative 1 over 1 as my slope. Well, let's look at this second one. Let's do the 10x. And again, see, whoops. Let's go ahead and do that a little better there. Sometimes my smartboard likes to go a little haywire on that spot. And again, here's what I'm talking about, divide by that 4, because I knew I was going to do the same thing. Oh, 10 divided by 4 is 5 over 2 minus 7. And in this case, the slope, 5 over 2, which when I compare them, is neither. Okay. So that's what we're doing here. Verify it algebraically, and you can use your calculator to also verify it graphically, but I would not use graphically as your sole way to do it. It's much easier just to get in the habit of solving for y, comparing the slopes. All right, that concludes this lesson. Again, feel free to rewind and go back, and the answers to all of these will likely be available online. Good luck.